So, good morning. So, in our last class, we were discussing the Java interaction with the database through the JDBC drivers. So, later on, we discussed the architecture of the JDBC followed by the different types of drivers. So, just let us look at the example of a complete Java code. Uh, so, in order to interact with the database, we have to import a package in Java, that is java.sql.star. So that will import so all the classes and subclasses that are present inside the SQL package. So then uh, within the main, we have to establish or to load the driver. So driver can be loaded using the API class.farname sun.jdbc.odbc.jdbc driver. So this is the name of the driver. And in some virtual machines, so it is mandatory to include the dot new instance function. Otherwise, in most of the environment, so this new instance API is not required. Then we can store the URL of the database, that is JDBC ODBC my sailor. So this is the URL of the database. Then once a driver is loaded, then the connection must be established. So driver manager dot get connection. Here we will pass the URL. So driver manager is a static class, which means we are not creating a object of driver manager. So once the connection object is created, so next we must create the statements. So in order to create a statement, so this is a normal statement, not a prepared statement. So unlike the one which we saw in our yesterday's class. So c dot create statement. So that will return the statement object. On this statement object, we will call the execute query function. So in execute query function, we will pass the query string, that is select star from sailors. So assuming that sailors is a table present in our database. Then on this particular result set, we can extract the metadata of the result. So this metadata of the result will contain the column headers and their data types. So that it is returned as a result set metadata. So yesterday we saw the database metadata itself. So database metadata will contain the information about all the tables in the database, and then we can also extract the details about a particular table using the metadata. But if we are running a query, it is not a standalone table. So a query may involve n number of tables. So in order to extract the metadata of a query result, so we can use the result set metadata class. So next we will be iterating over all the result set tuples using r dot next within a while loop. Then we will print the tuple followed by this just a slash int for our indication purpose. For int I is equal to 1 till the column count. So md dot get column count will return the number of columns in the result. So md is the metadata. So increment the counter. So within this, so each one will print the result set. So rs dot get string of I. So which means here, irrespective of the type of the attribute in the database, so we are printing all of them as a string. So that is using get string of I. So even though the value in database is of integer type, it can be converted and printed as a string over here. Then this slash is included so that it looks like a column for us. So finally, when we come out of the while loop, we'll close the result set. So anyway, everything whatever is written, that will be inside a try block. So you can observe over here. So as soon as we started the main method, so there is a try block. So we have to close that try block and then immediately followed by a catch block with exception e. So if there are any exceptions, so you can print a stack trace, so just for indication purpose. So this is a just a console application where all the interaction happens using Java console only. So it is these statements can be embedded in your lab programs also, if you have executed any in your fourth semester algorithms lab in Java. So in the same program, in between, these statements can be added, but the only additional thing that has to be done is the loading the Oracle jar file. So we have something called jar file for the Java in order to connecting it to Oracle. So that has to be added to the project. So if that is added, so then we can execute these statements inside that function itself, provided we have a Oracle database installed and all its URL is known to us. So with this, we will next look at the next another way in which we can programmatically interact with the database. It is the SQLJ. So this SQLJ, it is the here the J stands for SQL Java. So this was developed by SQLJ Group. So that is a group of database vendors and along with the Sun Microsystem. So this was developed to complement the dynamic way of creating a queries in JDBC. So unlike JDBC having a semi-static SQL queries, so allows us to compile and to perform SQL syntax check. So all those things can be done in the programming side itself. So which means the SQL syntax checking happens at the programming side of Java. So unlike in JDBC, which happens at the database side. So here, this is in SQLJ also, the variables are bound in the host language. So indicated by a colon. So you can look at the example. So all arguments are always bound to some variable. So in order to declare a SQL X, so it is always preceded with hash SQL followed by the variable name X is equal to, and a query we have written, that is select name rating into colon name colon rating, which means the name attribute and the rating attribute will be placed inside these variable. So here name and rating is a program variable, whereas these two are the database attributes from books tables, where SID is equal to colon SID. So whereas SID is again a program variable. So this way we can specify the query and the result will be placed in these two variables. So now compare it with the JDBC one. So in the JDBC, what happens is we have to use a result set, and on the result set we will place like this rs.getInt of 1. So then get int of 1 will return the SID, and on the SID will extract the strings. So using name is equal to rs.getString. So it is just a comparison of a syntax. Here what happens, directly it is placed in this variable. So whereas here we have to process the result set object. So in JDBC, we can dynamically decide which host language variable will hold the query result. Whereas in SQLJ, so it is determined at the compile time itself. And in SQLJ, we can create the iterators. So if multiple rows are written in the SQL query, so we can always have the iterator. So we can declare a variable like this: int sid, string name, int rating. So this is the Java variables. Then we can create a named iterator. So iterator will be like this: SQL iterator. So this is a keyword. So hash SQL iterator is the keyword followed by the name of the iterator. So our iterator type is sailors. So whatever it is there in capital, it is the type of the iterator, that is sailor, and it will be holding a integer sid, string name, and integer rating. So three values that this iterator will be holding. So once we declare the type of iterator, then we can declare a variable of iterator type, that is vSailors. So vSailors is the iterator of type sailors. So just like the objects and class relationship. Then what we can do, we can assign this vSailors is equal to hash SQL vSailors is equal to, we can write the query. So select SID comma name into these two variables, that is SID and name from sailors, where rating is this. For any query we can write. So the only thing is, whenever we are assigning it to a variable, so it has to be preceded with a colon. Then in order to extract the result, so it will be in the while loop vSailors dot next. Then we can access the individual attribute values using vSailors dot sid, vSailors dot sname, or if we have a rating, then we can use vSailors dot rating. So finally we can close this particular iterator. So when we use a iterator, so it looks very simple to us and also similar to result set methodology. So there are two types of iterators in SQLJ. One is named iterator, another one is positional iterator. So in named iterator, so we need both variable type and a name, and then allows the retrieval of columns by name. So just like the previous one, whatever we declared iterator, so it is a named iterator. So another iterator which we have is a positional iterator. So in positional iterator, we need only variable type, and then we use a keyword, that is fetch. So you can see the example over here: hash SQL iterator followed by the name of the iterator, that is sailors, int, string, and int. So we have not declared the variable name, only their type is given. Then again we will declare a variable of type sailors. Then the same query we will write, but here what we'll write, we will write inside hash SQL fetch colon sailors into colon SID colon name. Then what happens? So for each individual record, so this SID and name variables will have that particular tuple information. Then we can put end fetch to break out of the processing. So the difference between positional iterator and named iterator is, in named iterator, the names will declare along with the iterator itself. Whereas in positional one, so we'll use the fetch keyword to, for each tuple, it will be stored in the variable. So then we have call level interfaces. So a call level interface provides a library of functions to access the database. So the DBMS drivers are stored separately. Thus, the library used by the programming language is DBMS independent. So the programming language functions provided only an interface to DBMS driver. So driver is completely different than the host programming language. So driver in itself is a separate piece of software. So if we want to run the Java along with the Oracle, then we have to load the corresponding driver as part of the jar file. So the advantage of such an environment is, the development environment is not tied to a particular DBMS or operating system or even a development environment. So the separating of this programming language, the driver and the database, so we can change anything at any point of time in the application. We can change the database. If we are using Oracle, we can move to MySQL. If we are using a Windows platform, we can move to Linux platforms. Or if we are using the Java environment, we can switch the language also. So anything can be changed irrespective of changing the other entities. So that helps when we have the modular structure and a separate driver not integrated into the programming language. So there are some disadvantages, so which includes very low optimization is possible. Sometimes it is very difficult to optimize or impossible to achieve the optimization because all the things are not integrated together and they all will have just interfaces. Okay, so there are a few other key examples, that is SQL, CLI, Open CLI, command line interface, then Microsoft ODBC, so Open Database Connectivity. So just like JDBC, we have ODBC. So ODBC is for connecting to Microsoft objects. So Open Database Connectivity. So ODBC, it is another standard, unlike um, or just like JDBC. So the goal here is it makes possible to access any data from any application regardless of the database which we are using. So ODBC manages this by inserting a middle layer called as database driver. So the purpose of this layer is to translate the application data queries into commands that the Dbms understands. So what happens if we use the ODBC? So the database which we are using, it doesn't matter. So the ODBC will take care of converting all our commands to Dbms related. So it happens because we have multiple Dbms vendors or commercial softwares. So this is just a pictorial representation of how the things happen. So the operating system will interact with the ODBC manager. So in turn, ODBC manager will interact or calls the API of the programming environment. So programming environment will have its own API library. So the ODBC manager will interact with the system specific ODBC drivers. So this again system specific ODBC drivers will have the driver for different DBMS softwares. For example, a separate software for Oracle driver, Sybase, Access, Paradox, SQL Server driver, maybe MySQL driver. So these are the different databases. Oracle, Sybase, Access, Paradox, SQL Server. These are different databases. So for all of them, the drivers will be present in the ODBC. So depending on the programming environment and the operating system we are using, and the database which we are using, the specific driver will be selected and the mapping between the database will take place. So if we are using MS Access, then a different MDB file will be accessed. If we are using Sybase, then .syb file will be used. So depending on the database that our application is using, this ODBC manager will load the specific driver. So programmers task will be easier rather than choosing or loading a different drivers each time. So next we shall discuss the another concept, that is stored procedures. So stored procedures, it is often required to execute some part of the application logic directly on the database system. So instead of extracting the data from the database, processing it in the whole programming environment and computing the values, so sometimes it is necessary to run those part of application logic in the directly on the database system. So running application logic directly at a database has an advantage that the amount of data that is transferred between the database server and the client will be minimized. And at the same time, we can utilize the full power of the database server. So when SQL statements are issued from an application, the records in the result of the query needs to be transferred from the database system back to the application. So if we use the cursor to iterate over all of them, so and then process it and get the required result for us. So it will be a tedious task and a time consuming one, since we will be iterating over all the records. So in contrast, what we can do is a stored procedure can be used. So a stored procedure is a program that is executed through a single SQL statement that can be locally executed and completed within a process space of the DBMS server. So the results can be packaged into one big result and returned to the application. Suppose if we want to find the total of all the subjects of a particular semester student wise. So instead of extracting result of all the subjects, then find the total in the client side, we can do this task at the server side itself or on the DBMS side itself. So what happens is, if we are extracting all the students data multiplied by number of subjects, such many rows we have to process, and such is the huge data that has to be transferred from the server to the client. So instead what we can do is, we can process all it at the DBMS side, only the result has to be shifted out. So this greatly reduces the amount of data transfer that takes place between the client and this server. So if we are using a stored procedure, it can be greatly reused, because different users can use the same procedure or different applications can use it. So it avoids a tuple at a time return of records through the cursors. So this is the example to create a simple stored procedure. So create procedure followed by the name of the procedure, then create procedure name, then followed by a simple query. So that is select SID name count of star. So whatever query we can write, and then this query can be directly called using show number. So here this is a simple query. We can write any computation over here where we can compute the CGPA of a student itself. So we can write that particular query over here. So yeah. Stored procedures have different kinds of parameters. So since it is a procedure, it must take a parameter also, just like functions. So the three different modes are in, out, and in out. So if a parameter in is in, which means it is an input parameter, so for which we'll pass the value. So out means, so it's the output parameter, so that value gets assigned. So a parameter acting as both an input and output, it is written as in out. So another example of creating a procedure is create procedure, increase rating in sailor ID integer. So it means the sailor ID has to be passed to this procedure and it is integer. Another one, in variable increase integer. So again, this is a in means value we have to pass. So while calling this procedure, we have to pass two integer values. So what does it do? Update the sailor, set rating is equal to rating plus increase, where SID is equal to sailor SID. So which means here it is an update query that is being done in the stored procedure. So similarly, we can the computed result can be outputted using a out parameter. So stored procedure do not have to be written in SQL itself. So that can be stored in a separate file also. So this is the example. Create procedure. Top sellers. So input is an integer. So the language that we have written is in Java, and it is present in some jar file. So in order to call the stored procedure, so we can execute like this. So execute SQL begin. So declare section. So this is when we are writing the stored procedure in a separate file or a Java file. So exec SQL begin declaration. This is a declaration section. We are declaring two variables. Then now increase the rating of this cursor using the call, that is exec call increase rating colon sid colon rating. So this now calls the stored procedure. So which means we can call one stored procedure from another stored procedure or from a Java program. So this is when we are embedding in the Java. So now if we want to call it in JDBC, so what we can do is we can have a prepared call statement. So callable statement. So the different statements which we discussed, that is as simple statement, prepared statement and callable statement. So here we can use the prepare call statement. So the class name is callable statement, on the connection prepare call inside it. So we can use call is a keyword followed by the name of the stored procedure we can call. So if it takes any parameters, that has to be passed, then simply we can execute and iterate over the result set. So stored procedures are nothing but a functions uh, that are present on the database side, and some data processing or data modifications happen directly on the database side. So if we are using SQLJ, so we can declare a iterator, and in place of the SQL command, so which we have written in SQLJ, we can use the statement call show sailors. So where show sailors is a stored procedure, and then we can iterate over here. So the only difference in JDBC is the statement. So instead of that, we have to use prepare call, and its type is callable statement. So apart from these two, there is no difference on how a stored procedure is processed in JDBC programs. So next concept we have, that is SQL bar PSM. So all major database systems provide a way for users to write a stored procedure in simple and general purpose programming language that is closely aligned with SQL. So PSM is one such way. So in this, we define the modules, which are collections of stored procedures or temporary relations and their declaration. So we can declare a stored procedure like this: create procedure name followed by the parameters, local variables and the procedure code. And we can declare a function here: create function name returns SQL data type, local variable declarations and function code. So each parameter is a triple consisting of the mode, whether it is in, out or in out, parameter name and the data type. So a simple function is create function rate sailors In sailor id integer returns an integer, so declare rating, declare number results integer, set number results is equal to, then one query, if this number is greater than 10 then rating is equal to 1, else rating is equal to 0, and if return rating. So this is just a function syntax in PSM, where we will count the number of results, then if the number is greater than 10 then we will put a rating as 1, otherwise 0. So here what happens is, so we can use the if else and else if ladder, so all those programming things can be added together, so which is not possible in pure SQL. So this processing of result or updating or modification of data can be completely integrated in programming constructs. So that is if, else, switch, while, do while, so all those things. So that thing happening on a DBMS side itself, so all those things are put in a stored procedure, or this is the PSM construct. So PSM constructs include local variables, return values, and we can assign the variable values using set. Then we can use branches and loops. Then queries can also be part of expression. So which means we can write a query itself and its result will be replaced in the expression. Or we can use the queries naturally, cursors naturally without using the exec SQL statement. So these PSM or SQL constraints are used in very high level applications like banking applications or any other financial applications. So they will use these stored procedures or these PSM modules heavily. So if you are into that particular banking domain, and within that if you are into the uh, development for products, then these things you will be using in your professional career. So anyway, we don't have any laboratory experiments or executions on this particular stored procedures or PSM constructs. So we can stop here for today's class. So in our next class, so we can start the internet applications.